not on mute. Good. So thanks for letting me come and speak, and thanks for everyone who's turned up. I'm really excited to be here to talk about a technology that I think doesn't get shouted about enough. So tonight we're going to look at augmented reality development for iOS devices for .NET development, specifically using Xamarin, ARKit, C# and .NET. There are other ways of creating augmented reality experiences, but we're going to look at this sort of specific combination of technologies. So yeah, what I would ask is for people just to turn up their imaginations a bit as well, because I find that augmented reality is like a blank canvas for your imagination. So as you're watching this and you're learning about the different things that are possible, maybe you have a think about, oh, I wonder if I could do it for this or that. Conversely, if you've not got much of an imagination, then augmented reality might not be your natural calling. Clicker's not working. Yes, it is. So the obligatory about me. My name is Lee Englestone. I'm from Stockport, Manchester. Sorry, Stockport in the UK. And I'm the dev manager over at Interact Intranet. I have to mention that we're hiring. We're looking for senior devs to help take our intranet product and deliver it to even more customers. We have big customers like Domino's, the Co-op, PlayStation, like that. So we build an intranet product for big enterprise companies like that. But we are looking to get bigger. So we are looking for hiring senior devs. So contact me if that's something you might be interested in. I'm on Twitter, LinkedIn, YouTube, GitHub. It's quite easy to find me if you just search for Lee Englestone. That many Lee Englestones. I also blog at manchesterdeveloper.com, so you can see what I'm up to there. And if you are a .NET developer, you might be interested in looking at another website I've created called visualstudiotips.co.uk, which has about 40 or 50 tips for Visual Studio. So if you use Visual Studio every day, you might want to check that out. And a lot of the stuff that we're going to look at today, I've captured in another website called XamarinARKit.com. So yes, you can find me by Googling Lee Englestone, but I am not the only Lee Englestone. There's two of us apparently. I thought my name was quite rare. Apparently it's not. If you do search for Lee Englestone and you find someone who's like a stock car racer, that's not me. I don't have that interesting a hobby, I'm afraid. That's someone else who's a lot more interesting than I am. Okay, so just to set some expectations of what we're going to be talking about today. We're not going to be talking about HoloLens, other than to say there's a picture of me wearing the HoloLens, having not shaved for some reason, mixed reality toolkit, Unity, virtual reality, AR Core, which is Android's augmented reality framework, or WebAR. These are all great technologies with, I'm sure, lots of different use cases, but we're not going to be talking about those ones today, mainly because I've not tried them. So what will we be talking about? I'm going to be showing you how we can develop AR experiences if you're a .NET developer without an expensive headset like the HoloLens, which is about $3.5 grand, I think, last time I checked. Without writing Swift or Objective-C or having to learn that, without using Xcode, small caveat on that, because you need to run it once to deploy some certificates to your device, and without being part of the developer paid program. Everything I've showed you today is available to try and deploy to your iOS device free of charge. So this is specifically for iOS devices using .NET and C#, using a Mac, I'm afraid, because you still need to use a Mac to compile and deploy to iOS devices, and using VS for Mac specifically. So more specifically, the talk's broken down into three parts. We're going to be looking at an introduction to augmented reality, just because I don't know where everyone is at. I don't know if you're mainly technical or not, so we'll have a bit of a 101, I guess, for augmented reality. Then we'll look at the business of AR to discuss why we might want to be creating these experiences. And then we'll jump into the implementation that the .NET devs might be interested in. And specifically, we're going to be looking at these uses of augmented reality, I guess. Image detection, and what can we do if we detect an image in the scene. Plane detections, that's detecting horizontal and vertical surfaces. What can we do if that happens? Face tracking, facial expression detection, body tracking, animations, physics, and 3D models. And you'd be glad to know that all of this is kind of built into ARKit and SCENEKit, but we'll get to that, don't worry. So one thing I like to do before I jump in and talk about boring stuff is to kind of flip it normal talks on its head and just show you the end results of the kind of things that we're going to be looking at how we develop. So if I just jump over to my YouTube, and I'm just going to pick up some examples. And if this is not playing particularly well, it's just because we're doing it over Zoom. I assure you all these AI experiences are as smooth as silk. So let's just have a couple of examples. This is one that I created a couple of days ago. So I took a data set of stars in our galaxy and their relative positions in a CSV, uploaded that into my app, parsed that, converted them into XYZ coordinates, and now I can go around my room, click a star, and it will tell me a bit of information about that star and its relative position to Earth. So that was just knocked together in probably a few hours. Let's look at one more and then we'll get cracking. Okay, so here's another one. So this is taking a plugin for Blender, which we'll talk about later, which is a free 3D modeling tool, and using it to produce a 3D map of some terrain based on some a location. This happens to be around the corner from me in the Peak District, and then exporting that into our app and doing some clever things like getting it to rotate and animating it and pinching it smaller and larger. So that's the kind of experiences that we're going to be looking at today. Okay, but you can also try some of this yourself. I have created an app that brings together a few of these examples and put it in the store. I've never put an app in the store before, so I thought I'd give it a go, and it looks like I managed. So if you want, you can, as well as looking at videos, you can actually go ahead and download this and try out facial tracking as well, and a few other things. While you're there, give it a rating, preferably not 1 out of 5. Maybe I can get up the charts from number 162 into developer tools to slightly higher. Okay, so we've gone over this. This is the breakdown of the talk. The first part, the intro, then the business, and then the largest part, the implementation. Okay, so let's start. So what is augmented reality? Let's make sure we're all on the same page here. So I've looked at a number of definitions of augmented reality, and none of them I thought really rolled off the tongue. So I came up with my own. For me, this is as basically as I can sort of describe it, and it's making something look like it's there that isn't actually there. And I'm happy with that description. If my mum said to me, Lee, what is augmented reality? It would be a bit out of character for her. But if she said that, I would say it's making something look like it's there that's not actually there. Now, that's not to be confused with virtual reality. So in virtual reality, you put on a headset, your whole vision is occluded. So all you can see is what's being projected to you into your eyes through the app that's running on the headset or through the headset. Whereas augmented reality, there's still an app running, you can still see the world around you, but the app is also dropping in 3D models or items into that real world as well. Okay. So then what is ARKit? Now, ARKit is just one of many augmented reality frameworks. This is Apple's augmented reality framework that runs on iOS. It uses something very, very clever called visual inertial odometry, which I always struggle to describe and end up reading from my notes, but I'll give it a go. So the visual inertial odometry, it takes the camera feed from your phone that the camera's looking at, that scene, combines a number of hardware things like the accelerometer and the gyroscope and the compass to work out how you're moving the phone and which direction, and combines that with some computer vision. So it's checking each frame and seeing how there's differences in each frame, and all that's done sort of abstracted away from you, so you don't actually have to worry about that. But that's how, when we place a 3D model in the scene, it manages to keep its location as you move the phone around and pan back and forth. So that is Apple's augmented reality framework. It was ported to .NET by Xamarin so that C# and .NET developers can write C# code and take advantage of some of that clever stuff when it's deployed onto iOS devices. This isn't to be confused with ARKit as well. ARKit is Android's augmented reality framework. We won't be talking about that today. I've never tried that. We'll be talking about ARKit. So if you like what you see, but you're more of an Android person than an iOS person, maybe you want to look at ARKit, for example. So then what is Xamarin? Because not everyone might not know what Xamarin is. So it was originally a separate cross-platform app development toolset, existed in its own separate entity, where they developed a very clever thing where you could write C# and deploy to iOS and Android. It was so clever, in fact, Microsoft came around and acquired them in 2016. And since then, Xamarin has been rolled into Visual Studio. So you can just open up Visual Studio and create a Xamarin application and deploy to iOS or Android devices. Now, we're not talking about Xamarin.Forms. We are talking about Xamarin.iOS. Xamarin.Forms is a different beast when we talk about Xamarin.iOS today. So that kind of concludes what is augmented reality in the introduction. I told you it was quite small. So this takes us on to the business of augmented reality. Why would anyone want to create an augmented reality experience? What is the point? So when I talk to people about augmented reality, I get a few different viewpoints and at different ends of the spectrum. So one of them is Peter Jones. Sorry, I've not talked to Peter Jones, but this is him saying, that doesn't make sense. I don't get it. So sometimes I talk to people about augmented reality and they're like, why would you want to do that? I don't get it. What's the point? Which is fine. You know, that's absolutely fine. Then on the other side of the spectrum, I talk about augmented reality to people. I get this bottom left reaction, which is Deborah Meaden, I think, and Peter Jones this time saying, oh my God, this is amazing. This is going to be the next best thing. This is fantastic. And then it's a bunch of people that are in the middle, which say, it's impressive, it's cool, it's neat. I don't see how useful it is, but it's kind of cool, which is fine. All these are valid, but I kind of sit in there. This is going to be quite big over the next few years. So I want to be at ground zero, hence why I'm giving a talk on it. Okay. So we can't talk about augmented reality without talking about Pokemon Go. Now, for me, Pokemon Go was when augmented reality came of age. It proved to me that not only are people willing to wave their camera around or their mobile device and have an augmented reality experience, they quite enjoy it. And so much so that they're willing to pay for that, to the tune of $100 million is how much people spent. I can't remember it's how much people spent or how much was the revenue, but we're talking about seven figures. No, sorry, hundreds of millions of dollars were made by Pokemon Go in its first 20 days, and in its first month it made 207 million, which is a nice payday for the developers, as you can imagine. I never actually played Pokemon Go. I don't know if you have, maybe. So I've only got 2 slides on Pokemon Go. Don't worry, the whole thing's not about Pokemon Go. So just to put that into a bit more context, over the last 4 years, I've not got last year's figures, users have spent $3 billion inside Pokemon Go. So that's not a small sum. So it kind of looks like this augmented reality has legs, and if people are spending that much, it's going to hang around for a while, isn't it? Let's be honest. But it's not all about games and entertainment. We're seeing an increasing number of real-world applications and business models where augmented reality is an important factor. So this is an augmented reality experience where someone can try on different glasses frames without having to actually physically try them on. They can see what they look like on their face, the shape of the glasses, how they sit, size, the colors as well, and that sort of thing. Now that is incredibly handy if, for example, you can't leave your house and you can't go to the high street and try these sort of things on. So now this app I have tried, this one is called WANNA-Kicks. That's W-A-N-N-A Kicks. Now, if you've never tried augmented reality, I suggest you download this app and try it, and it might just convert you as to maybe getting interested in and thinking maybe this augmented reality stuff has a future. What it allows you to do is to browse through a catalogue of shoes, point the phone at your feet, and it will show you what that shoe looks like on your foot. And you can move your foot around, walk around in it, and it tracks it very well. And then you can go off and buy it if you want. Now, what we also have is an increasing number of manufacturers are creating 3D models for their products and allowing you to see what it looks like in your office, kitchen, whatever, before you buy. There's a couple of interesting things on this. So one is that there's been some interesting studies done, and they found that the conversion rate of people that have used AR to see what the product looks like before they buy it, the conversion rate is something like 300%. Don't quote me on that. I've not even got a reference for that quote, but we're talking hundreds of percent conversion rate if people try this. So if people try this, it looks like they are much more likely to buy the product. So that makes sense, because this slide here actually comes from, so this image comes from Google, and they're actually showing how if you exported this 3D model of your product into a format called USDZ, it's telling you how you can index it on your website so that you can go straight from your Google search results on your phone, click a button, and it says view in 3D, and then you can say view in your space, and in 2 clicks, you can see what that product looks like in your home, and then you can go to the store and buy it. Now, this is also happening in places like Currys or PC World, where you can look at how large flat screen TVs look in your living room. So you can see how large a 55-inch or a 60-inch TV will look in your living room. And it's also happening on Amazon, I think, and places like IKEA. You can see products and what they look like in your living room. If there's a book to be made or increase in revenue, you'll find businesses trying this stuff out. Okay, so far we've talked about mobile devices when it comes to our mobile phones, that is, when it comes to augmented reality, which makes sense because these devices are incredibly powerful. They're getting more and powerful all the time, and they're increasingly coming with an increasingly number of complex cameras. So it's not uncommon for some cameras now to have sort of 4 lenses on the back of them, and this sort of sophistication allows even more AR experiences, I guess, or more accurate tracking. But for me, where there's going to be a bit more of a revolution in augmented reality usage is when the augmented reality classes start hitting the market. And there are dozens and dozens of manufacturers all scrambling to trying to be first to market with these sort of things, to combine sort of something that's not too bulky, something that's powerful, something that allows proper augmented reality experiences. Now, I don't want to kid you that the first versions of these aren't probably going to be very good, but if you think about what the first version of the iPhone was like, when I'm on version 7, 8, 9, 10, 11, 12. So the first version of iPhone, if you look at it now, it looks a bit out of date, but it was revolutionary at the time. So in the same way, the version 1s of these glasses that come out aren't going to be fantastic. I don't think, I'll be perfectly honest with you, but the version 2, 3, 4s and 5s are going to be amazing. And I think these sort of devices are going to be the places we start consuming content. I think these are the kind of devices that are going to break our love affair with our little black screens, whether it's our laptops, our monitors, our phones that we always look down at. You know, we spend an awful lot of time looking at these devices. I think this is going to be how we consume content in the future. And it's going to be developers like us that are going to be developing interfaces and software for these devices. Just bear that in mind. So for me, the success of augmented reality kind of hinges on a number of factors, and this is kind of my very basic formula that is what going to discern whether AR sort of the make or break of AR. So we know we have the customers because $3 billion spent in Pokemon Go, and people being 300% more likely to buy things if they use AR. So we know we have the software because we have ARKit, we have AR Foundation, we have Unity, we have AR Core, Facebook are developing something called AR Spark, and I think there's a couple more that I'm forgetting. So we have the software able to create this. We have businesses trying these things out. And the people that have produced the first to do this are going to be the ones that be their competitors. And the kind of thing that's kind of slowly catching up is the hardware. So I'm referring to the sort of glasses, and I think once they hit the market, it's going to be sort of happy days when it comes to AR. That's going to be a huge market. So that kind of concludes the business of AR, so why we might want to produce our experiences. So now we're going to get stuck into the implementation. How do we create them experiences? We're going to metaphorically pop the hood and see how we can create these sort of things. Okay, so I'm not going to go into too much detail about how you set up these things initially. I still want to keep this relatively high level, and I've got a limited amount of time to sort of level you up on this sort of stuff. But the basic process is you don't need a paid Apple developer account. You just need an Apple ID. You need a Mac. You need to create the project in Xcode, deploy to your device, and when whatever bundle ID you use for that project, and once you've deployed it to your device using Xcode, you can put Xcode to the side, launch up Visual Studio for Mac. You reuse that bundle ID, and you can start writing C# and .NET to create these experiences. Yes. Small caveat there, said we wouldn't talk about Xcode, but we do need it initially. So then another sort of gotcha is when you creating the app the first time, you want this single view app here. You don't want this augmented reality app one here. So don't get me wrong, there's probably different ways to do this sort of stuff. This is just the way that I've tried, and this is the way I'm sort of telling you that I would advise you to do because I know it works. So then that's Xcode. On the right, we've got Visual Studio Mac, very similar. What we want is this app in the iOS section, and then we want this single view app there. And then once you've done that, you're very close to being able to deploy it to your device. There are a couple of other hoops you have to go through. When you deploy to your device, you have to go into the developer section and trust the developer, or yourself in this case, and say, I trust this developer who's just put this on my device. And you also need to give the camera permissions as well in the app. Okay, so we can't really go much more further until we talk about SCENEKIT, because ARKit is amazing. It's what makes augmented reality possible. But what we are going to use an awful lot of in these experiences I'm going to show you later is in fact something that's got nothing to do with augmented reality. It's called SCENEKIT, and this is Apple's 3D graphics framework, and this has been around for a long time before ARKit ever came onto the scene, if you excuse the pun. So what people were using SCENEKIT for was to create games, I think, to a large extent. But this allows you to place 3D models and things into a running app. It incorporates a physics engine, which is kind of neat, and particle generator, which I've never used. But we're going to use a lot of things from it, like geometry, material, lights, and I don't know why I put cameras. I've never used cameras. But yeah, this is SCENEKIT. And just to show the differences of what we'll be using to create these experiences in SCENEKIT and ARKit, I've got a really handy slide, which is far too pretty for me to put together. So full credit to Ryan Davis. He puts a good slide together, so I've just borrowed it. So what we can see is anything in blue, and so usually suffix with AR, comes from ARKit. So we've got some anchors here, which we'll talk about later. And these are placed in our scene when we automatically detect a plane or an image or a face. We'll talk about AR session in a minute, and AR configuration. And then everything else in green comes from SCENEKIT. Although I do doubt about these, which begin with AR. Anyway, so we will be using these node actions. I'm going to refer to them as animations in this talk, and then also node geometries and all this sort of stuff here, like the nodes. We'll talk about nodes. They're like the building blocks that we're going to put together. So yeah, so what we're going to look at is, I guess, a combination of ARKit and SCENEKIT. Now, one of the things that makes this sort of magic possible is this class called AR Scene View. And what that does is when its session starts running, it puts the canvas or the view to be the feed from the camera, and is magically showing any 3D models that you're putting into your scene. It's really hard to describe. It's probably a lot easier if I show you. And yes, I think I've mentioned all that. So when this session is running, there's a number of things we need to think about. So I need to mention that as your session is running and you move your camera around, it's trying to make sense of the world around you. So the more you move it around, the more it's going to make sense of your surroundings, okay? And you'll see that later. And also it's limited by a number of factors. It's limited by the amount of light in your environment. So if you're in a very dark room, it's going to struggle a little bit. So augmented reality in the dark is almost out of question. And to quote someone else, AR in the dark would be boring anyway, I think was their quote. The other kind of things that are going to limit you is the surfaces that you're looking at. So ARKit works best, sorry, augmented reality in ARKit works best if you're not looking at reflective materials, things like mirrors or glass. And it doesn't work very well if you're looking for planes, that's a flat surface, like walls, if you've got a very plain wall. So if you've got a wall that's just white, it's featureless. It's very difficult for it to figure out what one part of it is compared to another. Whereas if you've got wallpaper or carpet or a busy environment, it can track all these interesting points. And as you move it around, it can remember that, I don't know, there was a guitar in the corner there, or the wallpaper was over there. So then I mentioned we're going to be using anchors in the scene, and these are points of interest. We can manually place these, or they're automatically placed depending on the kind of experience we want to use. So if we are using the facial tracking ability of ARKit, it's going to drop a face anchor into that scene, and as you move around, it's going to track the location of that anchor. And we can also place other things in the scene relative to that face. So if we moved like a hat or something, this is how the glasses thing worked in the earlier example. So then that takes us to the coordinate system, which you need to kind of get your head around before you start placing things in your scene. But fortunately, it's a very, very simple 3D coordinate system, and you'll probably be very familiar with this. So when it comes to sizes, it works in a floating point, using floating point types, where 1F is 1 meter. That's very easy to remember. So if I'm going to place a cube or a sphere in the scene, and I give it a value, a width of 1F, I'm effectively making it 1 meter wide, okay? Similarly, if we want 10 centimeters, it's 0.1F, and 1 centimeter is 0.01F, as we'll see later. The XYZ coordinates work largely as expected. So if you want to add something, put something to your right, you need to give its X coordinates value plus a plus value, and if you want to make it appear on your left, you give it a negative value. If you want it to appear above you, give it a plus Y value, and then if you want to make it appear below you, a negative Y. Now the Z index I need to highlight because it's a bit of a gotcha. It works, what I say, backwards to forwards. You'll notice that the negative Z index is actually in front of you, and the plus Z index is behind you. Don't ask me why it does that. But if you're not aware of this and you're like me, you'll be trying to put a sphere plus in front of you by doing, the Z index, I'll put it plus 1F in the Z index, and that'll put it a meter in front of me. No, it will put it a meter behind you. And you won't realize that until several hours banging your head against the brick wall, looking all the way around your room until you look behind you, and it's been hiding behind you the whole time. So just remember, minus Z index is the one in front of you, or you cry like I did. So the other thing to mention with this coordinate system is wherever you started your session or the app when your phone was launching, that becomes what we call the world origin. That is 0, 0, 0 in this world, in this location around you. So if you place something into the scene and you don't give it, if you don't explicitly say, well, the X, Y, or Z coordinates are, it will put it at 0, 0, 0, which is where you're standing. So if you add something to your scene, don't explicitly set the coordinates, you're going to struggle to see it unless you move back a little, and then it'll be there in front of you. So that's the coordinate system. Then I want to talk about these things that we're going to see a lot of called scene nodes. Now that's, again, is a class, and I like to refer to these or think about them as your sort of Lego bricks of augmented reality or ARKit more specifically, in that you can give them shape, and you can give them color, and you can tell them how to behave. And it's not until you add a few of these together that you get anywhere near like an interesting experience. And it's a lot like Lego bricks. They all come in different shapes and sizes and different uses, but one Lego brick by itself is a bit boring. It's not until you start putting them together until you can make something quite interesting. Okay, this is where I could jump out into some code, but I'm going to skip it because we're going to look at the same code later on in a later example. Right, geometries. So these are built-in shapes that we can give to our nodes to tell them what we want them to look like. Check I've got my pen. Okay, so these are the built-in shapes that we can use. So going from left to right, we have got something called a box or a scene box. And that's a box, not a cube, because we can also make it like an Amazon package, which is flat and long, or tall and thin, or it's just a cube is always the same length, width, height, isn't it? Like a dice or something. So this is a box. Here we have a capsule, which looks a bit like a tablet, I guess. There's a cone here. A lot of these I've never ever used. And we have a cylinder. We have a plane, which I use an awful lot of. The majority of the stuff I do is using these 2D planes, because what we can do is put images on these and have them floating around, and it looks kind of neat. Then we've got pyramid, which I've never used. If the ancient Egyptians ever had augmented reality, I imagine that'd be very useful to them. Then we have a sphere, which I have used a little bit, but isn't as useful as you would think unless you're trying to show a spinning planet or build a snowman. Then we have mine went black there for a second. This donut shape is a torus, okay? Torus. And then on the far right, we have a tube. And then the one that I always forget that's hiding in plain sight is this geometries one here. Sorry, it's a text one. It's called scene text. And I tend not to use them because I find they don't play ball. Instead, what I tend to do if I want text in a scene is put it in a PNG, a transparent PNG, have the text being the only thing that's not transparent, and then put that on a plane like this. And then that's how I put text in a scene. Now, this is where I will dive into a code sample. So I'm going to show, don't do that. I'm going to show the basics building blocks in the code that enables the augmented reality, and then I'm going to show how I place those sort of geometries in the scene. Okay, so going to my code sample that I prepared earlier. So when you create your first project, it's going to be blank. But some of this is very boilerplate code that once you've done it once, you can just copy and paste, copy and paste, copy and paste, and those are your building blocks for your future augmented reality experiences you want to create. So here we've got a geometry shapes view controller, which, do you want? I'm going to zoom in a bit. I always forget this bit. Let me zoom in so you can see it a bit bigger on your screen. That inherits from UI view controller. Then we have this magic maker class, this AR scene view. Then in the controller for this class, we are instantiating that AR scene view, and we can provide it some default values, which we don't really need to go into now. Then we add that scene view as a subview of our current view. And then what we do is some more boilerplate code is when the view loads, we just set the frame of the scene view to be this view's frame. I always struggle trying to explain what that's actually doing, but you kind of just need to trust it works, because I've never ever had to change some of this code in a lot of the experiences I put together. Then we'll come back to get material. In this view did appear, there's again some boilerplate code that always runs in all the AR experiences I've created. So we're calling this base view did appear. Then we are telling the session on the scene view to run. So now it's starting to look at it's starting to feed the camera into the canvas and starting to try and pick out interesting points in the scene to remember where it is. Then we always pass in a tracking configuration. There's different types, but for your basic bog standard scenarios, you'll default to using this one. Later on, I might show you how we might pass in a face tracking configuration or image tracking configuration, or there's a few that body tracking configuration, and that all that does is allow you to set different properties. But again, we don't need to go into too much detail to what these are. Then all that above is boilerplate code. Then what's happening in a lot of the different experiences that I'm going to show you is from this line down. Okay. So here we're declaring a size, which is 0.05f. And if you remember correctly, that's going to be about 5 centimeters. Well, exactly 5 centimeters. Then we are setting the Z position to be 0.4f. So who can remember what that is? That's 40 centimeters effectively. And we're setting the minus. We're setting the Z value to be minus. We want to put it in front of us, right? So that's 40 centimeters in front of us. Okay. Then what I'm doing is creating a new instance of this scene node, which if you remember is these Lego bricks that makes everything else. Then I'm setting its geometry, and I'm calling this static class. I'm saying call the create method on this scene box class and pass it some parameters, which happens to be the width, height, and length, and this chamfer radius, which is this last parameter here. You don't have to worry about that too much. That's just how sharp the corners of the box is. Do you want it to be like a dice, which is nice and round, in which case you'd have to increase that, or do you want it very, very sharp? You can cut your finger on it, kind of, and that would be your default 0. So once we set the geometry to be a box, we still won't be able to see it. It would be invisible. So we'd need to set the material for it. So we do that by instantiating the material, and here I'm calling this get material method and passing it a UI color of red. So we need to go up to the get material method. So as you can see, we're instantiating the scene material and we're setting its diffused content to be color. You don't have to worry about what that's doing too much. Just know that we are setting this material's color to be red. So now we have a box of a certain size that's going to be red. We just need to set its position. So we instantiate this way of declaring a position, this scene vector 3, and we're setting it X, Y, and Z coordinates. So this is telling me I want it to appear straight in front of me. Don't worry about moving it left to right. Don't worry about moving it up and down. So that's X, that's Y, but I want it that 40 centimeters in front of me. Okay, so that's all I need to create this red box. And then if I scroll past these other geometries, I'm saying in the root node of the scene view, you get used to this, I swear, add as a child node this box node, and then when your app runs, you will have a red box floating in front of you 40 centimeters away from you. And then we've got some more boilerplate code, which is just what to do when the view disappears, or I'll probably delete that, in fact. So then I'm just repeating the same for different geometries, different sort of shapes. I'm doing it again for sphere, torus, and these have different parameters to put because they're going to have different attributes. So for the torus, it's going to be something to do with the thickness of the ring and the radius of the ring and stuff like that. And the sphere one, and it takes one parameter, and that's the radius, I think, or the diameter. Radius, the radius of what you want to create. So that is how you would you create your first augmented reality experience. It'd be pretty boring, but that would get you a red cube 40 centimeters in front of you when you run your app. Okay, but as I said, that's gonna be pretty boring. So one kind of tip I'll give you, and I've got a few of these, is things are always a bit more interesting when they're moving around. If you place something in the scene and it's static, it can be a bit boring. So what I tend to use is these things called scene actions, but I refer to them in this talk as animations. And we can animate a number of properties on these scene nodes. We can animate their opacity. So we can have a node to be invisible and fade in to be 100% opaque, or vice versa, have it there and then fade it out. We can set animated scale, so have it start small, make it grow in size, or again shrink. Or we can animate its location and say start over here, but I want you to move over here over a certain period, or we can get it to rotate and spin on its axis. We can wait. You might think, well, why would you want to wait? It's because you can group these animations. You can either group them so they all happen simultaneously, So you can say, I want this node to move towards me, increase in size, and appear, appears as in have its opacity change from 0 to 1. I want all that to happen at once, or we can sequence them and say, happen one after another. So you might say, okay, this sphere, I want to move from here to here, then I want it to grow, and then I want it to fade away in that order, so we can sequence these. And with these animations, we can also repeat them, so we can say, just spin indefinitely, or just spin once, or spin X times. We can also use easing as well. So with animations, it can be a bit jarring if the animation just starts and stops, a bit like, I like to describe it as a bit like accelerating a car to get to any sort of speed. You're not going to go from, you really don't want to go from 0 to 30 like that, because that would be bad. And conversely, you probably won't want to stop from 30 to 0 like that, because that is also bad. You're actually accelerating, aren't you, as you get up to speed, and then you're decelerating again. That's what easing allows you to do. It starts the animation off slowly, gets up to speed, and then slows it down again. So then I do have an example of animations. Now I tend to use these QR codes quite liberally, because whenever I show videos over Zoom, it's very slow and jagged, and I don't want people to get the wrong impression and think, oh gosh, there's augmented reality using ARKit. It's not very smooth. It is super smooth. So what these ARKit codes go to is the video on YouTube that you can always watch at a later date if you want. But let's have a look at these examples. So I've got a very, very simple one, which is just a rotating. This animation is just rotating this sphere on an axis over by 360 degrees over, I think, about 5 seconds, and I've set the material of that sphere to be a map, and it's wrapped itself by itself. It's clever enough to do that, and I've also got about 5%, 95% opacity on that, so it's 5% transparent. You can't possibly tell that. And so my second tip is that things generally look a lot cooler if they're semi-transparent. They look just a bit more futuristic. I don't know why. Got science fiction over the years to blame for that. And then the other one is the example I've got for using animations is this one that I put together for showing the periodic table. So what this is doing, it's changing the position of a node, and it's also fading them in and over a period of time. And then I can move around and click on my screen, and it will detect if I'm clicking on a node, and I'm again saying, I want you to animate a bit closer towards me, please. And then when I touch it again, animate it away. So again, that's just how you can use movement and animation to achieve something interesting in your scene, because things that don't move are a little bit boring, I find. Okay, so then one interesting use case for augmented reality that comes right out of the box in ARKit is plane detection. And so what we could do is detect the walls around us, or any sort of flat surface, I suppose, and the floors as well. And you might think, well, why would you want to do that? There's a couple of reasons. So firstly, there's been some businesses that have built entire business models on this. So, or should I say, augmented the business model like this. So I've seen some businesses that allow you to show what different wallpaper or paint looks like on your walls before you go out and buy it. And also you need to know where the floor is and where it begins and stops before you can sort of place things on it. So things like your IKEA do an app where to place furniture on in your environment. So they need to detect the surface of your desk. So if it's going to try and place a lamp on it, or the floor, if it's going to try and place a IKEA Pohang chair on the floor. Yeah, the other thing to mention on this is that as you move the camera around and it sees more of the scene, it understands more, and it sounds silly when you say it like that. So what I mean by that, if you look at the floor in one direction, it knows there's a plane there. If you start moving the camera around so it sees more of the floor, it's clever enough to work out, actually, this plane's bigger than I thought, and I'll demonstrate that in the next video as well. And it places a plane anchor when it detects it as well. Okay, video time. Oh, would have been an early one. Nope. Yep. So what this is doing, if you see any little yellow dots, that's a debug feature you can turn on that says, show me feature points. And you'll notice that where there's interesting areas in my study, there's lots of little yellow dots. That means there's lots of feature points that it can remember. Whereas you can see on this white wall here, this very plain white wall, it really struggles to identify feature points and therefore struggles to identify it as a plane at all. It's not until I sort of move around a bit more that it can also sort of figure out this is the floor. Okay, there's more floor over here. I'm going to expand this plane over here. Now, we also talked about lighting. My room is quite a dark room, so that's also going to affect its ability to be able to properly map out and detect things. So in a well-lit room or outside, you're going to have a lot better chances of doing this. And eventually, as I move around, it detects all the surfaces in the room. Okay, so that's plane detection. Then another use case, again, comes out of the box of ARKit. You don't have to put in any third-party tools for this, is image detection. So what we can do is we can package up certain images along with our app and say to ARKit when that session's running, if you detect this image in your scene, it will, first of all, it will place an anchor where it detects that image, but then it fires an event with that location. So we can do interesting things. So we can say, I know that image is over in this place, so I'm going to place something else at that place. I'll show you what I mean in a minute. But as well as, you can detect up to 100 different images as well. So if you wanted, you could have images for each card in a 52 deck of cards and give it different file names, and you know which card it was looking at, for example. So we can bundle along with the app, as I mentioned, but we can also dynamically add images that we wanted to detect. And you might think, well, why would we want to do that? Well, that's because we might not always know at compile time what images we want to detect. So the best way I can describe this is if you're developing an app and you want to be able to identify the front cover of the 100 best-selling books, yeah, then you're not going to know that at compile time because it's always changing. So what you could do is you could go off and hit the Amazon API and say, go get me the 100 best-selling books. While you're at it, bring me back the front covers of those books. Load that into memory in your app. And then as you're moving around and you might detect the best-selling book, it fires this event. We could do something interesting. And then maybe at that point, we could make another call to Amazon and say, right, okay, I know what book I'm looking at now. Go get me some reviews of that book or some more details or the pricing details, and then bring that back and then put that information around the book that you've identified. So that's just one use case I can think of where you might want to change what you're detecting at runtime. Okay, got 3 examples of image detection because it is that interesting and it's really good things to practice with when you're first starting out. So in the first video, what we're doing is when it detects my business card, and I've saved the image of my business card along with my app, I'm telling it to add a 3D model to that location. And then once I've done that, when I manipulate that image, that business card, it knows it needs to manipulate that 3D model because I've anchored it to that detected image. That's all handed for you. You don't have to do it. It does lose tracking occasionally, but again, limited by the lighting conditions and whatnot. So that's kind of neat. So you can have other nodes and 3D models to a detected image. The other thing you can do is, I forgot what it was, add other images to the detected image. So here, again, what I've done is when it's detected my business card, all I've done here is added 1, 2, 3, 4, 5, 6 different images and said, just set the XYZ coordinates of these 6 different images to be in relation to the image you've detected. Set my headshot to be a bit to the X minus X coordinate, set these social media ones to be in the Y and the X, Y, and Z. And then when I manipulate that, it manipulates that as well. So I did mention that transparent PNGs work really well. They do, as you can see here. These are just transparent PNGs with some text locked in, and you just add them as in like you would any images, and bingo, you've got text in there. and then I could take this further if I wanted. I could touch my screen on one of these social media icons and then maybe pull in my tweets or something like that if I wanted. Okay, so that is that one. And then the last one I've got for image detection is how to, well, I just did this to see if I could do it, but you can detect the location of the detected image. This time I'm using the reverse of my business card. Oh, that's just me, that. I'm actually playing a video, and then it's clever enough to know that when I change the orientation of that image, change the orientation of that video that's playing. Again, it's just kind of neat. So just those 3 examples should already be giving you ideas for the kind of things you could do with this sort of stuff. Okay, so that is image detection. Then again, built into ARKit, I'm starting to sound like a broken record, but I can't emphasize enough what is just out of the box if you use ARKit. We have body tracking. So what this allows us to do, and what ARKit does if we're using the body tracking configuration, I think, is when you point your camera at a person, it can track, let me just count this, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, no, 4, 5, 6, 7, 8, 12 major joints in the body. And then from that, it can infer some minor joints in the body. So it tracks 12 major joints, and then it can infer the position of some other minor joints in the body. And there's something else you can do is, if you've got it so it can track the your body, you can also create 3D models and what they call rig that 3D model to your movements as well. Okay, so at any point when you're running body tracking and you've detected a body and you've got a body anchor in that scene, you can say, get me the XYZ coordinate positions of any of these joints. Some of these are the major ones that are tracked, and some of these are the ones that are inferred. And you might think, well, why would you want to do that? So a couple of examples I've seen with body tracking has been in exercise programs. So just to watch people's form. So you could track how many squats. I don't lift, so yeah, no joke there. Track the number of squats you do or the number of press-ups you do or something like that. I've also seen it used in a scenario where it's looking at someone's posture from a side and it's watching to see if they're slouching, because we know the position of these major and minor joints. We can infer the angles between them and the distances. So I've seen it where you can see if people are starting to slouch, if they've got a bad back or something like that. So that's just a couple of use cases. Okay, so let's jump into the code. That's wrong. I copied and pasted that. It doesn't use the front camera. The facial tracking uses the front camera that we use, that we'll look at next. But let's have a really quick look at a video that's me just being silly. And I was very, very happy when I got this to work, because I couldn't find any C# examples that got this working. So yeah, as you can see, it's pretty smooth, even when in the low lighting conditions in my study. There you go, just me dancing around, looking silly. There you go. You have to think about your own applications for this, but I thought it was pretty neat. Okay. Wrong way. Okie dokie. So what's next? Then we've got sort of facial tracking. So you can track up to 3 faces in the scene, and this does use the front camera by default. So I need to mention this is facial tracking, not facial recognition. Okay, so there's been a lot of bad press for facial tracking recognition software recently, mainly because we've got sort of governments using it for a reason perhaps it shouldn't be. But this isn't facial recognition, this is facial tracking. So it will tell you that this face is in the scene, it just won't tell you whose face it is. It's not that clever unless you add some more code to it, some bespoke code, okay? And then when it detects a face, it will place a face anchor in the scene. So I've got a couple of videos for this. So I've got a boring one and then a not so boring one. So the boring one is when I first got it to work, which is this one, which makes me look like a scary mime. So it's detected there's a face in the screen, and if you can lip read, that's me saying it's working now. And this is all, that mesh, that geometry that it creates is just built in. So you don't have to do that. All I've done is make it white and with a tiny bit of transparency so you can see through it. And again, you might think, well, why would you might want to do that? Well, we've already looked at business case, a real world business case for this, where if you know the position of the head or the face, you know then how to put other things, 3D models on it, for example, glasses. Okay, so you could build an app that lets you see what different baseball caps look like, what different glasses look like, what different facial tattoos look like. So these are just a few examples. So on the face of it, sometimes you might think, well, what are the real world uses of this? There often are. You just need to either use your imagination or just look or think a bit harder. So then I will get to the code sample, don't worry. I just get a bit carried away sometimes to forget the code samples. Then, as well as tracking faces in a scene, again, built in ARKit is the ability to track up to, 52 different facial expressions. And when I say facial expressions, I don't mean happy, sad, angry, envious. These are all emotions. Those aren't expressions, right? So what I mean is it can detect if your mouth is open or if you're squinting or blinking. And there's 52 of these, and I've not even been able to get it to identify these because I don't know how to contort my face in a way that it wants. So I don't know what mouth dimple right is or what mouth roll upper is, but I think I've got mouth shrug lower to work, and some of these are easy. And what it does is it's not a Boolean value. So it's not like mouth open, mouth closed. These are all on a scale from 0 to 1 in this floating point data type as well. So if your mouth's only 50% open, you'll get 0.5. And what that allows us to do is determine all of 52 things. We can simultaneously detect how much are we doing on that face. So I could stick my tongue out and blink, and it'll be able to detect, is it doing that a lot? Is it doing a little bit? So there's quite a lot of stuff you can do with this. So I've got another video and even a code sample for this. Let's do the video first. So this, rather than the solid mesh, I'm using this lined mesh. And what I'm doing is saying if it detects smile, change the mesh to one color. That's eyes open, that's eyes squint, that's mouth funnel, mouth tongue out, cheeks puff, eyes wide again. And again, you might think, well, what are the use cases of this one? So because we're able to detect and react to the degree of which different parts of the face are moving, one use case scenario I thought of was maybe, I'm not medically trained, so apologies if I get this wrong, is perhaps if someone's had a stroke, and I know in a stroke, perhaps certain parts of the face can become paralyzed, and perhaps, and I think I'm right in saying that it can take time for those muscles to return to being able to fully function. So you could be able to track the progress of the ability of being able the user to be able to move different parts of their face if they're recovering from a stroke. That's just one example I can think of. Let's jump into the code for this one because we've not looked at the code in a while. That's going to be called something like facial expression detection. So again, this is all boilerplate code, copied and pasted from previous examples. And the only things that's different in this one is in the view did appear, we're using this AR face tracking configuration now. We can set the maximum number of faces we're interested in, because maybe we're not interested in tracking 3 faces. Maybe we just want to track 1. Then we set that running. And then what we're doing is we are assigning this delegate. And what this delegate is doing, this is a class we're instantiating, and this is the class that is going to handle the things that happen and that ARKit's detected. So when it detects a face, it's going to add a node to the scene. It's going to add this anchor, and it adds a node along with it as well. So here the code is saying if the anchor is of type face anchor, which it is, then I want you to create a facial geometry based on what you're seeing. Then I want this node that you're automatically placing in the scene. I want it to, this geometry to be the geometry you've detected. And then I want the fill mode on that material that you've detected to be lines, not solid by default. And then, so that's what it's doing when it first detects it. Then what it's also doing is when this did update node is fine, which is all the time when the face is moving around, or you move your face or smile, whatever. This did update node fires, okay? So again, we're checking if the anchor is face anchor. And sorry, this code has been written for readability, so it can probably be optimized, by the way. So don't diss my code, okay? So then what we're doing, so if it's a face anchor, get the face anchor, then I'm saying, so it's been a while since I looked at this code, get me some geometry, then set my expression threshold to be 0.5. So by that, I don't want it to be firing every time there's even a hint of a smile. So if I'm smiling and it's got like a 50% confidence that I'm smiling, or it's then yeah, I'm trying to smile. Okay, so then I'm saying if the eyes wide left is greater than the threshold, or the eyes eye wide right value is greater than 0.5, then change the face color to green. Okay, and I'm doing that for all these different shapes. So here I'm detecting if the tongue's out. Okay, so if we think the tongue out is more than 50% out, then I would change color to red. And then this change face color is pretty simple. All I'm doing is saying, create me new material, set the material to be the color I'm passing in, and then set the geometry that I'm also passing in its material to be that one. Sometimes you need to play around with this to understand it, but that's effectively what we're doing. Okay, so that's facial expression. So as well as these really boring shapes that we can put into our scene, we can put some more interesting things in there. We can put 3D models in there. And these ARKit supports a number of formats of 3D models. I think the ones I've used are this DAE ones and .obj. The DAE is called the Collider format. I don't know what produces it, but it's certainly the type that I've implemented before. So you can go off to Free3D or Sketchfab or some other places and download a 3D model in one of these formats and load it into your app and place it on a business card or on somewhere else it's detected, or just have it floating there. Or you can create your own 3D models as well, which is something I'd like to get a lot better at, because I think I've got lots of ideas of the kinds of 3D shapes I want to put into my scenes. So you'll probably be able to notice that I created these football shirts here because they're just how well they're modeled. So I'll show you the video for that one. So for this example, I had an idea of, wouldn't it be great if you went to the pub? Do you remember pubs? If we went to the pub and you could share an augmented reality fantasy football lineup of your fantasy football team with your mates around the table, and you could just like project it onto the table. I thought, wouldn't that be neat? So what ARKit also allows you to do, I believe, but I never tried this, is share that session. So it could be that you have an app, and whilst you're projecting it, someone else could try it instead, and then maybe someone could click a player and say, oh, well, I wouldn't have him in defense, maybe put someone else in there. I thought that'd be kind of neat. Also, I've got sort of no football affiliation, so I don't really support a red team. That's just complete coincidence. So if you're a Man United or Liverpool fan or someone in a red kit and you're cheering, you can stop right now. Got no time for that. Okay, so then as well as these very basic rubbish models that I've created, we can place other 3D models in. And I've kind of already showed you this terrain one that I placed in the scene before, and I will show it really quickly if I can find it, because I quite like this one. So for this one, I thought, well, wouldn't it be great if I was actually stood on that hill, which is just a few miles down the road, and I could project a 3D model and walk around it using my phone and think, okay, that's a bit of a steep incline, because I'll be perfectly honest with you, if I'm looking at an OS map, it's hard to check. For me, it's hard to tell if something's steep or not. One hill looks like the next, whereas this one gives a lot better indication of just how the terrain contours and maybe the best approach or paths to take. And for this one, I also had the idea of, so I took loads of photos of this walk as I went around, and wouldn't it be great if around this floating terrain I also had the photos of the walk I took. I could even have it pointing at areas of places on this map that I took them, or maybe a marker and I pressed that and then the image appeared. Again, you just need to use your imagination. You're going to get a lot more out of augmented reality if you've got a good imagination. Then, so we've seen so far how to put things into the scene. It's going to be even more interesting if we can interact with those items in our scene. So we're going to look at UI gestures. So it turns out, again, built into ARKit, what we can do is, in fact, this might be more SCENEKIT, so apologies, is we can translate movement gestures on the front of our phones. So whether we're pinching in or out, rotating or panning or swiping, if we do that on the camera and we happen to be doing that on a 3D model, sorry, on a node in that scene, we can get it to react to that event. So we can do some quite interesting stuff. I've got an interesting video and a boring video. I'm not going to show you the boring video, don't worry. So here, I'm placing 2D images onto a surface I've detected. And I've called an API, the Unsplash API, and said, get me images of pizza. Developers love pizza, right? And then I'm panning, and it's detected the pan. And then you can say, it can automatically, with a little bit of code, detect the starting and ending X, Y coordinates that are moving around. So then I pinched and I'm saying, right, I want to increase the scale when you detect a pinch. And when I rotate, I want you to rotate that 2D image in the scene as well. So one example I had for this was maybe if you're moving house. I've not moved house in a while, but I imagine you still get all these leaflets that look of all these photographs at the front of what the houses look like. Maybe you can, if you're looking at a different number of different properties, you can place them on a virtual table like this, or virtually on your real table, should I say. And then maybe you got like a maybe or a no or a yeah, let's go visit that house pile. And then maybe the houses you're interested in, you can click it on the screen, and maybe you can hit another API and throw up the internal or external images of that property all around you. So going from 2D to 3D, which would be a really neat use case that I thought. Again, just use your imagination. You're only limited by your imagination with this stuff. So lighting, it turns out lighting's quite important when it comes to placing items in augmented reality, because our eyes and our brains use lighting to infer a lot of detail. It uses lighting to infer how far or close something is away. If I want to touch something that's over just in front of me, the amount of light that's falling on it and the position of the light, it helps me detect where that is. If you don't believe me, tell me how often you've reached for a glass of water in the middle of the night and you knocked it over because you've not had enough, your brain's not had sufficient light to determine where that glass is in relation to your hand. Okay, so then what that means is that, it means a couple of things. So if we place images into our scene and we don't accommodate for lighting, it can make those experiences look fake. If we place a very bright object in a dark seat environment by accident, it's going to look fake. If we place an object in a scene that looks dark in a very light environment, it's going to look fake. Likewise, if we place an image in a scene and everything around it is casting a shadow except that fake object, it's going to look fake. So we can use lighting to cast shadows and do that, as we'll see. Okay, so there's different types of lighting in ARKit, or is it SCENEKIT? I think it's SCENEKIT, but I won't go into that because you don't really need to know that at this point. And I generally only use one of them, which is directional anyway, to produce my shadows. So we're going to go look at a video, which is really interesting, I think. So here we're placing a cube 10 centimeters above the floor. So it's detected this plane, which is the floor, and then I placed this cube above the floor, and so what it's effectively doing, and it sounds silly, is it's projecting. I've got a fake light source shining fake light onto a fake object, casting a fake shadow onto the kind of like fake plane on the floor, but it looks real. And you just got to think about this. If you didn't see that fake shadow there, then your brain would struggle to understand how high above the ground that object is. But because it's there, I can immediately infer roughly where that object is in that environment. So again, this is think tip number 3. Always add shadows to your experiences that you're producing. It just looks a lot more real and effective, in my experience. So then, built into SCENEKIT, we have physics that we can make use of. So when we place these nodes into our scene, by default, they're not solid. They can pass through each other, but we can make them solid by calling this create kinematic body method, which I don't know why they didn't just call something like make solid. It's probably a physics term. And then what we can also do is say, I want this node to appear as if it's being affected by gravity. I pull straight down towards the center of the Earth until it hits another solid node that I put underneath it. And we do that by calling create dynamic body. And again, I don't know why they can't just call that effect by gravity or something like that. Again, probably physics thing. The other things we can do is apply force. So games have been using this for a while. So we can have maybe a sphere, do dot apply force in a certain direction with a certain, trying to think of the term for force, newtons, I don't know. And then you can maybe fire it off. And I've seen games make use of this and firing spheres through toruses, donut shapes as a basic game. We can also set things like a node's fake mass or friction to have it affected by fake physics in different ways. Yeah. So we kind of think one experiment we want to do, I've not got around to with this yet, is create like a wall of cubes and then just knock it down. I thought that'd be quite neat if they all just then collapse and tumble down. So that's physics. Oh, I've got a video for that one, I forgot. You'll see what I mean by the lighting as well. You could see this is one of my early experiments, and because I've not accounted for lighting, because I'm using great gory colors, it just looks fake. So I've got a 2D plane that I've said create solid effectively, and then I'm dropping cubes onto this plane. I've said have the cubes affected by gravity, and then they hit this plane, stopping them, and you can see the ones that are rolling off the sides are falling infinitely, and they'll just keep falling and using up memory, by the way, even if you can't see them anymore. So if you ever do that, you need to account for that. So yeah, if I did that again, I'd do something a bit differently. I don't know why some of them jitter around as well. I'd need to look into that. I'm probably not setting the mass or the friction or something like that sufficiently. Okay, so that's physics. There's a whole bunch of stuff you could do with physics, which I've not had time to play around with. So getting towards the end of the talk now, really. So I just want to run through some stuff we've not discussed, because I'd hate for you to not know it was in there. So we've got body occlusion. So by that, I mean early versions of ARKit, when the session was running, if you placed I don't know, a 5 meter cube, let's make it a big one, away from you, and then someone walked in front of it, you would still be able to see the cube, even if someone, all the time, even if someone walked in front of it. But more recent versions of ARKit have got this thing called body occlusion that you can turn on, where it's clever enough to know, actually, someone's walking in front of that, you need to sort of hide the thing behind it a little bit, and because someone's in front of it. Then we talked briefly about session persistence. Sorry, no, we talked about sharing sessions. Session persistence, I've not tried this, but allegedly you can, if you've moved your camera around your environment and you've saved all them, you can save those feature points and then reload that if you want. You can share sessions across different devices. Again, I've not tried that. Again, so that you can, if you're projecting something into your scene, other people could see the same thing on theirs. Then object detection, and what that allows us to do, I have tried this actually. What this allows you to do is, in the same way, when we've got examples that are identifying images, we can get them to identify objects. By that I mean we can enter what's called like scanning mode of like a 3D teddy bear, real life teddy bear, and move the camera around it, and it will save the general shape and where the feature points on that bear lie. And then later on, if you save that way, and then later on you can enter scanning mode, and then as you're moving around your camera and you moved it to look at that bear again, and this can be from a few angles, it will detect, oh, I know what that object is. You've got, you scanned it earlier. So yeah, that's one thing you could do. That's object detection. And then we've got something interesting called constraints. So we can limit how we want these nodes, these Lego building blocks to behave. Now I've used these in an interesting example. Let me show you this. So for here, what I've done is created what I call a 3D photosphere. And what I've got is just 2D planes, hitting an API to get me a load of images of cats. Oh, and then what I'm doing is I'm placing an invisible node at the beginning. So I've not given it a material or even a geometry, in fact, and I'm setting a constraint on these 2D planes to say, and the constraint is called the look at constraint. So for these planes, these nodes, I've said, look at that central invisible one. And that's one way of being able to achieve this sort of angled approach without having to work out all the complicated maths of what should this angle be if I want to face it in a particular way. So that is the look at constraint. Another constraint is the billboard constraint. And what that does, it allows, if I had a 2D plane, similar to these, I could have it so it always faces the camera. So wherever I moved, it would always face the camera. So that's the sort of the billboard constraint. We'll use that less, if I'm honest. Then I also mentioned that there's also geolocation now built into ARKit. Yeah, ARKit. So that you can say, place a 3D model, I think, not tried this, at these latitude, longitude coordinates. So then, don't forget you've got GPS built in the phone, of course. So I could say, put a 20-foot teddy bear 3D model in the park down the road. The latitude coordinates are this and this. Then hopefully, as I walked down the road, went to the local park and moved my camera around, I should see a 20-foot stuffed penguin or teddy bear or something. Yeah, or something more useful that we use in geolocation. Then the other stuff that I also mentioned that ARKit's even more impressive when you combine it with other technologies like real-time communication in SignalR or voice recognition. So I could write a .NET Core console application that's using the system.speech namespace so that I could to listen for certain phrases. So if I said red, blue, then I could maybe open a SignalR socket that is talking, that app's talking to, that the same augmented reality app's talking to, and have a SignalR hub, and then broadcast that event, and then the augmented reality app would be notified that, and then it would say, oh, I need to change this to red or blue or whatever that's been, you could talk about. So real-time SignalR you could use together, I guess. And then LiDAR is a feature that's available now on the most recent versions of iPad Pros, I think. And I think it's also on iPhone 12s or the iPhone 12 Pros, which I've not got yet. And what that does, it allows you to map your environment to a very high degree of accuracy, and then export that as a 3D model and import it elsewhere. And do clever stuff with it like that. I've also played around with the idea of using another framework of Apple's called its Vision Core framework, where it's clever enough to know that if you're, this is not augmented reality, but if you're facing your camera at banana, it's like, I know that's it, the app will say, I know with a 95-degree confidence that's a banana. So I thought that would be quite neat to use with augmented reality somehow, but I've not thought of a use case for that yet. And then cameras, I've not used at all. So I don't know why I've included that. So as I mentioned, a lot of these samples I've included on a website of mine called XamarinARKit.com. And then they've got, I use the term lesson very loosely. They're not really lessons. They're just a title, an image, a video, the code sample of how that was achieved, and then a short description of what's actually going on. I think it'd be a bit unfair to teachers to actually call it a lesson. Just then to summarize, we talked about the business of AR, what it is. We looked at some of the things that we can use in SCENEKIT, some of the built-in functionality into ARKit, like plane detection, image detection, face detection. You can achieve this just using the Mac, Visual Studio for Mac, and an iOS device. Then so you can start using C# and .NET to create these things today. There's nothing stopping you. And I'll just return to an earlier point I made, that this is increasing in popularity, augmented reality, and before too long, you're going to see more and more job openings for augmented reality developer or designer, and it might be, you in the future, someone listening might have a job as an augmented reality developer, because that's the way things are going. So, I'll also mention that I've wrote a book on this, and it's a lot of the stuff we talked about today, but it's in a bit more detail, in a bit more of a guide form, so you could try this stuff out for yourself. It's not published yet, but it is on Amazon if you search for Lee Englestone. So if you are interested and you're looking to take your first steps, then there's a book available soon. I think it's going to be published in May. The publisher won't tell me exactly. And then other than that, I just want to say thank you very much for having me and letting me talk. I've really enjoyed it, and I hope you've got something from it, and it's got your imaginations running away of things you could create yourselves.
Yeah, thanks, Lee, and thanks everyone who stayed till the end. The recording from this talk will be up on